exercise 9.13D gets us to back to some of the more typical molecular shapes that we can encounter. This SO3, total electrons, 6 from the sulfur, 6 from each oxygen, but there's 3 oxygens, so it's 3 times 6. So we have a total of 24 electrons. As always, I put the first element in the center and put the other ones around it. So sulfur in the middle, 3 oxygens around it. I connect them with lines. Each line is 2 electrons, so I've just used 6. There are 18 electrons left. I start putting them around the outside in pairs, working my way around until I get all the way here, and at this point I am out of electrons. That I've got 24 total electrons. Problem is, sulfur does not have an octet. So I need to make one share. You can see that again, that I go from having 8 around that oxygen and 6 around the sulfur, and I switch over to having a double bond so that now everybody has 8 electrons. Central atom has 3 pairs of electrons. Remember, a double bond, this double bond counts as 1 pair of electrons when we think about geometry. They're all bonding pairs, so this would be trigonal planar. You have to know that table so that when you see this Lewis structure, you can remember 3 bonding pairs, no non-bonding pairs. That's trigonal planar. Now the reality is that this would have resonance structures. That double bond could be in any of these 3 places. And that just depending on how I happen to draw it, I could put my double bond here, or it could be over here, and it could even be down here. And what we know is that it really is in all those places at different times, so that we don't see the experience of having 2 oxygens 1 distance away from the sulfur and this third oxygen a shorter distance away, because double bonds are shorter than single bonds. So these are resonance structures.